Assalamualaikum and very great day to my beloved judges. My name is Nur Hanani binti Nur, such as presenter, Dr. Mazatul Zihar binti Ahmad as supervisor for my project, which is thermal and mechanical properties of regenerated cellulose of natural fiber reinforced polylactic acid composite. It is a systematic review. For table of content, it contains introduction, literature review, methodology, expected result, and conclusion. In introduction, I will explain about research background, problem statement, and objective. Research background. The increases awareness on global environmental issue among consumers, industry, and government result in increased demand for product created from renewable and sustainable resources due to non-petroleum based, biodegradable, low risk to human health, animal, and environmental. Natural fiber reinforced polymers composite, categorized as a green composite materials, is one of alternative. Ionic liquid is used to replace harmful organic solvent in pre-treatment cellulose. It has the ability to break down the strong intra and intermolecule interaction found in natural fiber cellulose and dissolve it. Regenerated cellulose reinforced PLA composite have been developed, biodegradable biocomposite which must sustainable. Properties mechanical and thermal research aim to improve of long-term durability, short time in degradations, and anti-flammable. I conduct this project to analyze on the effect of cellulose content and size on the thermal and mechanical properties of polylactic acid PLA composites. And I conduct on qualitative analysis in order to determine the optimum of cellulose content and size on the thermal and mechanical properties of polylactic acid composite in this study. So the objective is to identify the studies on the regenerated cellulose of natural fiber reinforced PLA composite form, then to analyze the effect of different size of cellulose and cellulose content on thermal and mechanical properties polylactic acid composite form. Then to correlate the optimum thermal and mechanical properties of regenerated cellulose of natural fiber reinforced polylactic acid composites. The problem statement I identify when doing in this research project is composite film is unnaturally sourced and non-recyclable material normally. So, and then the source and the demand. So previous research, many of previous research only focus on plant fiber polymer composites. So it not focus at regenerated cellulose that is reinforced to biocomposites. And then harmful pre-treatment method. Normally, previous researcher use the pre-treatment methods of cellulose from natural fiber using carbon disulfide that is not totally green and cause harmful to human and environment. So in literature review, the polylactic acid. Okay, the synthesis and chemical structure must to know to increase the properties. So it's use direct polymerizations and ring opening polymerizations to increase the molecular weight. So the structure they have a tree which is PLLA, PDLA, and then PDLLA. Okay, the physical, mechanical, and thermal properties is same. We must know the elastic modulus, tensile strength, and then the melting temperature and glass transition temperature. This is physical properties, and then thermal stability and degradation. So the PLA also is biodegradable. So why is the rate of PLA biodegradations is influenced by molecular weight and also the degradations temperature. So PLA is biodegradable because the process of PLA biodegradations is take 2 weeks only and completely disappear in the soil around 3 to 4 weeks. And then natural fiber reinforced composites. Classifications of natural fiber. have three, which is animal fiber, plant fiber, and also mineral. Okay, and then the classifications of natural fiber, which is divided by two. The biodegradability, based on biodegradability, which is non-biodegradable biocomposites and biodegradable biocomposites. And second is based on polymer matrix, which is biocomposites, and which have two parts, biocomposites and whole grain composites. The limits the use of the natural fiber in polymer. It have poor adhesive. Cellulose is hydrophobic in nature, while polymer are hydrophobic. And then irregularity in shapes. So the ionic solution as pretreatment may help it to solve this limitations problem. So the advantage of natural fiber is greener base materials, it renewability, low cost, low energy productions. Some are total biodegradability and environmentally. And then it is greater specific stiffness and specific strength. So the impact when we use this natural fiber reinforcement composites, it minimal impact on economics and also reducing the greenhouse effect. Next, cellulose. Cellulose have a repeated unit of D-glucose connected by B1 for glycosidic link. It have hydroxyl groups present in each repeated unit link to hydrogen have play vital role in crystallines. Okay, so it has a crystalline and amorphous area. Insoluble in conventional solvent due to strong hydrogen bonding between polymer change. And cellulose also have nanocellulose, viscous, fibrillated nanocellulose, cellulose microfibril, and microcrystalline cellulose have converted based on applications. Okay, and then mechanical properties cellulose, concentrations, and cellulose crystallinity. Okay, high cellulose content and cellulose crystallinity are desirable for plant fiber to be used in structural reinforcement. Okay, then the size of cellulose, we have three, divide three, which is microfibrillated cellulose, MFC. It is homogenized under a high pressure. It tiny structural unit of plant fiber, and also MFC increase tensile strength, improve barrier properties, and smoother surface. Okay, and then cellulose nanocrystalline (CNC). Okay, CNC is a needle-shaped entities cellulose. The crystalline, it have the crystalline region extracted from cellulose microcrystal. Okay, it has high impact ratio, high surface area, high mechanical strength, and a liquid crystalline nature. And then cellulose nanofiber (CNF). Okay, CNF have both crystalline and amorphous cellulose. It is very interested in research because of them transference, lightweight, and strong durability. For thermal and mechanical properties, in this research I focus on Young modulus, tensile strength, and also the thermal properties, which is the thermal stability and degradations temperature. For Young modulus, it defines the strength level at the maximum load, thus the stiffness. Okay, for tensile strength, it is the load per unit area the material can withstand, exceed load till it breaks. So for the thermal properties, it is important role in polymer behavior and to react in a variety of ways. Actually, for thermal properties, we use thermogravimetric analysis (TGA), usually used in for for research about the thermal properties. Ability of a plastic to withstand various degradation process, toughness, elasticity or strength at a particular temperature. Must increase because composite material become stiffness. Thermal and mechanical properties must be increased due to because composite material to make the composite material become stiffer, and then it can be a more load and will thus undergo less deformation. For methodology, in this project I use Prisma method for systematic review. Prisma is more accurate and reliability, and Prisma is also the combinations of systematic review and meta-analysis. For resource, many databases can be chosen as resource, but I use Scopus and SciDirect because of the advanced tool and for smooth in research. Eligibility and exclusion criteria to select the reliable journals depends on publication years, language, document, and source type, subject, and also subject area. Process of systematic review. So first, we identifications. So the we record the research found in the source selected, which is Scopus and SciDirect, and then we screening, which is remove and exclude the unnecessary, and reliability, which is the full text article access, excludes that not focused to my topic, and then I include the selected studies include in the term quantitative analysis to be for this project more accurate. Expected result: the cellulose of natural fiber is pre-treatment with ionic liquid reinforced polylactic acid composite film is expected to be analyzed using Prisma method was successfully developed. And then the comparisons effectiveness of cellulose size and content via systematic review confirm the increases in tensile strength, young modulus, thermal stability, and degradations temperature. Next, the optimum of cellulose content and size reinforced PLA composite achieved by meta-analysis is expected enhance the effectiveness, range of optimum tensile strength, young modulus, thermal stability, and degradation temperature of regenerated cellulose, cellulose and PLA composite films. For the conclusion, this project provide comprehensive information and act as reference on determination of optimum content and size of cellulose for future research on thermal and mechanical properties of regenerated cellulose reinforced PLA. It correlate on data to achieve the objective stated. When doing research for these several obstacles occur due to limitations of this study about the related topic. That's all for me. Thank you.